amazing. Oh my gosh. Now my self-worth has skyrocketed. Damn. Oh my god, I've got subscribers. Oh yeah. All right. Oh, that's how I started. All right. So let's take a look at 2b. Okay, so this is how we do it. First of all, in exponential functions, there are a gazillion parent functions because every time you have a different base, that's a different parent function, right? If I think back to my aerobics, this is y equals 2 to the power of x. This is y equals 10 to the power of x. This is y equals 1/2 to the power of x. How about y equals a million to the power of x? How about y equals 0.001 to the power of x? Right? Like, there's just so many variations. So there isn't one parent function. What that means is, in order for us to write the equation, we need to be told what is the base. In this question, we are told that the base is 1/2. Okay? So that's an important piece. What is the base? What is the base function? Well, or the parent function, it's 1/2 x to the power of x. All right. It is reflected in the x-axis. That means that's a vertical reflection. That means that A is going to be negative. Now, I'm also going to say you don't have to copy stuff down. If you like to just listen and you want to print my notes later, you are very welcome to do that. Okay, this is where you get to choose how you learn best. So if you want to sit and just listen and watch and print my notes later or copy my notes later, cool. I really won't take offense. I might ask and then you're like, miss, I'm just listening. Okay, but really, please do that. All right, first of all, reflected in the x-axis, that means that A is negative. Next, wait, I'll underline it so you can see where the purple came from. Next, turquoise, vertically stretched by a factor of 3. That means my A is -3. Horizontally translated 2 to the left. That means I'm talking about my D, and it's -3. Thank you. -2. And then 2 units down, so that means my C is -2. Yeah.
Would we say it's +2 or would it just
Once you put it in the equation, the D is -2. When we put it into the equation, it will become a +2. So this is what we do. So f of x equals, and let me write down where the letters go. A, some kind of B, right, whatever the B is. The K goes out front here. X minus, the D goes here, and then the plus C goes here. This is the formula. What I like about this formula is the 2 orange translations are the ones that affect the X, and the 2 light blue translations are the ones that affect the Y. Just to note, oh yeah, the X ones are right together there. Okay, so for this specific function, I'm going to write f of x equals, well, my A is -3. Then in brackets, I write the 1/2, right? That's what's different. I don't have a K, so I write x plus 2. So this is where you swap the negative D into a +2. Yeah?
Is it okay for the x plus 2?
Like that?
Yeah.
Sure. That's fine. Does this make sense? All right. Let's try another one. Okay. The function f of x is 9 to the power of x. So I know it's going to look something like this. And now let's put in all the details. Reflected in both the x and y axis. Oh, so there is a vertical reflection. There is a horizontal reflection. Vertically stretched by a factor of 3. Okay. Now watch this. This could look like a 39. So there's 2 ways you could show that the 3 and the 9 are separate. You could either put a dot to say, hey, they're being multiplied, or you can put brackets around the 9, right? I'm going to move this a bit. So I got negative. Horizontally stretched by a factor of 2. This is tricky. So if they're saying by a factor of 2, they are telling us that that is the 1 over k. Okay, when they're saying horizontally stretched by something, they're giving you the 1 over k. And so that means that the k is 1 over 2. Okay? So that goes in front of the x. It's translated 3 up. So there's no horizontal translation. Watch this. If there was a horizontal translation, you must use brackets. Let's say it moved 1 to the left. You have to use brackets, okay? So that because the k has to be factored out. But in this case, we don't have a horizontal translation, so we just leave the x, and then we go 3 up. Okay? Next, let's look at question 3. And I think I won't have to do all of them. I think that what's happening is you're kind of like, how do I do this? Let's start with A. So we are asked to solve for x. In the past, when you had to solve for x, all you do is you isolate x. So you do SAMDEB, right? You undo BEDMAS. You do the opposite operations to find out what x is. Or if I had x squared equals 9, you'd be like, oh, let's take the square root, right? Let's do the opposite operation and let's get that x is plus or minus 3. Well, we don't know the opposite operation of an exponent. You will work on that next year. So we cannot do opposite operations in this case. We can't undo an exponent. So the only thing we can do is make it so that the bases are identical. So if the bases are the same, we can we can surmise that the exponents are the same, right? So I can write, since bases are same, I can say, therefore, 2x equals x plus 4. So since the bases are the same, that means the exponents are the same. Does that make sense? And so the trick to this question is to change the base so that the two sides have the same base. And then what's important, see, I have this horizontal line. If I didn't have it, if I said 2 to the power of 2x equals 2x plus 4, 2x equals x plus 4, do you see the communication mistake? I'm basically saying this equals that, but it doesn't. So the way to separate them is you can just put a horizontal line to say, okay, two separate ones. And a therefore, because it's implied that, well, since the bases are the same, therefore the exponents are the same. Does that kind of make sense? All right. So, and then what we do is we just solve for the x. So now we can do opposite operations to solve for x. So I got 2x minus x equals 4, x equals 4 in this case. Let's try something harder where the bases are not the same. So let's do B. Okay, now the bases that we are, so possible bases. And I'm looking for the smallest base possible. 1 will never be a base because I can't go 1 to the power of something to get any other number. So we might have 2 to the power of stuff. We might have 3 to the power of stuff. We will not have 4. Do you know why? 4 is 2 to the power of 2. Will we have 5? Yep. So basically, I'm looking for my prime numbers. Can 6 be a base? I know it's not a prime number, but can 6 be written as 2 to the power of something or 3 to the power of something? It can't. So 6 is a possible base. 7 is a possible base. Is 8 a possible base? Because 8 is equal to 2 to the power of what? Good. 9? 3 to the power of 2, right? Onwards. Like, there is more, but I'd say this is probably as high as we'll go. So in this question, you're looking at these possible bases saying, which one am I trying to make both sides have? So when I look at this question, question B, which base do I want each of them to have? 2. All right, so the first half, the left side is fine. The second, the right side is not okay. So watch this. I can write 4 as 2 to the power of 2. And then I keep the regular exponent. And now I'm like, oh, this is just power to power rule. So when I have an exponent to the power of another exponent, what do I do with those two exponents? We multiply them. Oh, so all it is 2 to the power of 3x plus 2. So look at this. After this is algebra. But do you understand how we got here? Do you want to ask me a question? Yeah.
If you have like the 2 from 3x plus 2, can you like factor it into?
This one?
No, like on the other side, you have like 2 and then 2 power 2.
Could you multiply it?
Then I multiply 2 times 3x.
Absolutely. Yeah, so watch this. So then I'm like, I write my line, which sort of says, hey, we're starting something new. Because the bases are the same, therefore, 2x minus 3 equals 3x plus 2. And then, yes, I distribute the 2. I basically solve this equation to find out what x equals to. Yeah.
In the bottom line, what is the 2 and what is the 3x plus 2?
Where did it go? Or where did it come from?
No, like
This 2?
No, the one above this.
This 2?
Yeah.
It's here. That's where it is. I'm just writing the exponents. Do you see that?
Yeah.
Okay, good question. Yeah.
I don't get the basic stuff. Like you.
So basically I'm saying so in grade 11 math, we don't know how to take an exponent out of the exponent. Okay? In grade 12, you will learn that. So for now, we can't take anything out of the exponent. The only thing we can do is to make the bases identical. And so then it's like, well, if I have 2 to the power of 3 and that equals 2 to the power of x, well, x has to be a 3. So what we're saying is because they're the same base, that means this and this has to be equal to each other. So we're saying straight line, since the bases are the same, therefore the exponents have to be equal to each other. Okay, so we got 6x plus 4. 4x minus 7. X equals minus 7 over 4. Okay, that's just algebra. Let's take a harder one. Which one is hard? Let's take E. C or E? Actually, let's start with C. Because in this one, what might be a bit tricky is you might be like, okay, let's make 27 have a base of 9. Can I do that? No, because 9 to the power of 1 is 9. 9 to the power of 2 is 82. Can't do that. 9 is not the base we're looking for. Let's look at our list of possible bases. Which base should we use?
3.
Okay, so what we're going to do here is rewrite both sides so that they have a base of 3. So 9 becomes 3 to the power of what? 2. 27 becomes 3 to the power of? Good. Okay, I'll let you do the rest. Do you see that? Okay, let's look at question E. Is that the one I wanted to do? Well, actually, we can figure that out. Let me make one up. Okay, I'm totally making this up. I don't know what will happen of it. I think it'll work. Okay, let's try this orange one. So this is a nice challenger. And with this one, with this type of activity, what you'll see is the more you practice, the sooner you'll know which base you're looking for. Any guesses which base we're looking for? 3. Why is it definitely not a 2? It's not an even number. Okay, why is it definitely not a 5?
Not 5 or 0.
It doesn't end in 5 or 0, right? 6, well, that would be an even number. So it could be 7, but I'm looking at this and I'm like, I know 27 can be a base of 3. Okay, so let's do the right side first. So I know that I can write 27 as 3 to the power of 3. Do you see what's kind of nice? What's going to happen?
It's gonna multiply.
Yeah, the denominator will cancel out. Thank goodness. It's super cool. Good. So I got 3 to the power of 3x minus 2 over 3. So the 3's cancel out. So on the right side, it's nice and simple. Okay, let's remember this little trick. 1/3 equals 3 to the power of
Negative.
Okay, so if it's in the denominator, the exponent will be a negative. All right? Okay, not so bad. So if you want, you can break this up into several steps. You can say, okay, I know 729 is going to be negative 1 to the power of x, right? I'm going to take it out of the denominator. Okay, and now let's try to do this in our head. 729. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is, I think, 43. I think it's to the power of 6. Yeah? So then I'm like, wait a second. Okay, 729. So let's simplify. 729 to the power of negative 1x. Right? Do I need to write the 1 there? No. And then I'm like, okay, 729 is 3 to the power of 6 times negative 1x. Oh, so that's going to be 3 to the power of negative 6x equals 3x minus 2. Right? We're going to get some kind of fraction. Right then, we're like, okay. Therefore, we can say the exponents are equal. We get negative 7x equals negative 2, and x is 2 over 7, some kind of fraction. That, like, the later part is algebra. The important takeaways and the questions you want to ask is around changing the base, finding a common base for the two sides. Did this help? Spending all this time, this half hour on the homework was good? All right, so the quiz is up to and including that lesson. What I'm going to show you now is not on the quiz. That make sense? All right, let's... All right, we are moving on. Oh, share this tab. Oh, wait.